Hello, and welcome to Minerals, Rocks, and Fossil Talks. I'm your geology teacher, Jen, and it's time for Throwback Thursday. Today, we are learning about Norman L. Bowen. He was a Canadian geologist who changed the course of igneous petrology as we know it. And the internet had very little to say on this man. For shame. Don't worry, I knew where to look. In a textbook, because that's where the information was the best. So Bowen studied chemistry, geology, and mineralogy at Queen's University in Kingston, Ontario, and then he went on to get a PhD at MIT because he's a little smarty pants. The year he graduated, he joined the Geophysical Laboratory of the Carnegie Institution of Washington, D.C. as an assistant petrologist. This is where he would spend most of his professional career. And I'm telling you, he left, he came back. He left, he came back. He just couldn't get enough of this place. Bowen's biggest contribution was for his work in phase equilibrium studies of silicate systems as they related to the origin of igneous rocks. In other words, how and why igneous rock composition varied so much. Because it does. A lot. He went on to study some of the classic igneous rock sites around the world, such as the Bushveld Igneous Complex in South Africa, the East Africa Rift System, and the Fen Complex in Norway. He did a lot of work in labs on silicate systems containing iron oxides and systems containing volatiles, primarily water. From all of his studies came the Bowen reaction series. This was to help determine the sequence in which silicate minerals crystallize from a melt. How exactly could that be determined? Well, he took powdered mafic igneous rock and brought the temperature up to over 1200 degrees Celsius so that it would melt. Then he cooled it just enough to cause part of it to solidify. Then he quickly submerged the remaining melt in cold mercury. This process, which is called quenching, is a sudden cooling to form a solid. This turned any remaining liquid into glass, trapping the early forming crystals. And he did this many, many times at many temperatures and found that as new crystals formed, chemicals were extracted preferentially from the melt. Thus, the chemical composition of the melt changed as it cooled. So here's a diagram to kind of give you an idea. So we're starting at 1200 degrees Celsius, and as things start to crystallize out of the melt, the composition changes. Make sense so far? Cool. So here is what Bowen's reaction series looks like. We've got different things crystallizing out of the melt at different times. On this side of the diagram, you'll see what the composition is. We go from ultramafic to intermediate to felsic. And then on this side, you'll see that the temperature goes from high temperature to low temperature. So high temperature melts are going to be, or high temperature crystallization are going to be ultramafic, whereas low temperature crystallization are going to be felsic. We found that calcium-rich plagioclase, like this, and olivines were the first to form out of a melt. Then, as the calcium plagioclase would start to react with the remaining melt, it created more and more sodium-rich plagioclase. Some of the olivines would react to the melt and form pyroxenes. During these reactions, some of the iron, magnesium, and calcium atoms would be removed from and taken into the crystallization process, leaving the melt enriched with silica. So the more and more sodium-rich plagioclase continued to form, while pyroxenes would become amphiboles. And then amphiboles would in turn become biotite. Throughout this process, crystals continued to settle out. The last minerals to settle out are quartz, K-spar or potassium feldspar, and muscovite. He observed that The plagioclase showed a progressive, continuous change from calcium-rich to sodium-rich plagioclase, as you can see in this diagram where it says continuous series of crystallization. And the olivine side showed a discontinuous sequence of crystallization in which each step yielded a different type of silicate mineral. So lots of things going on. Crazy stuff. I hope you enjoyed learning about Bowen's reaction series. Actually, I'm going to make it so you can still see this while I talk. This month is all about igneous rocks. So if you like it hot, this is the month to tune in. Tomorrow we're going to take an in-depth look at Purosaurus, the giant caiman, for Fossil Friday. And then on Monday, we're going to start talking about magma. So, hope to see you on both days, and I will fossilize you later.